This video is about finding oblique or slant or diagonal asymptotes. So I'm going to cheat slightly because if you pause it and read, it says without a calculator, find the equations of the asymptotes. But what I'd like to do just for the very first one is to get an idea of what this function looks like. So I'm going to graph this on Desmos. So if I come out of there and go to Desmos, you might put it into your calculator or Desmos and get a function like this. But be careful and always try and zoom out, and you've actually got a function like this. Now on this, you have two asymptotes. You have one asymptote that's vertical and one asymptote that's diagonal. The diagonal one, I'll show you in a minute exactly where it is, but it's going, well, I'll show you in a minute. And then the vertical one is quite straightforward. So I've got an idea of what it looks like, and I'm telling you there's two asymptotes. So let's go back in and have a look at the question again. So I hope that you know already that we can look at the bottom of this. We don't want that bottom part to be equal to 0. So one asymptote will be x is equal to -2. So that's the vertical one. Now to get the diagonal one, or the oblique or slant one, we are going to do some division. So 2x squared plus x plus 3 divided by x plus 2. Now you've all done long division before, so we'll actually just do long division as a bit of practice on this one. And there are other ways of dividing this out, but we'll do a bit of practice with long division. So 2x squared divided by x gives me 2x. Then I multiply by the 2, so it gives me plus 4x under here. And then we take that away, so we get -3x and 3. And then we divide the -3x by x to give me -3. And just to finish this off, I times by 2 to give me -6. That gets added on, that gets 9. So the remainder is 9. Now, actually, I'm not concerned about the remainder at all. This part here, the quotient, that's 2x minus 3, and y equals 2x minus 3. That is my diagonal slant oblique asymptote. So just to show you exactly where that comes on the graph, I'm going to go back to the graph. So y equals 2x minus 3. We're also going to have a look at these two things here, the domain and range, while we're on the graph. So 2x minus 3, y equals x minus 2. So going back into Desmos, if I reveal now, there's my diagonal asymptote, 2x minus 3. And if I zoom in, you can see that it's basically never going towards that asymptote, the vertical asymptote here. Now, if I also want to find the domain and range, the domain, x can be any real number apart from -2. And y, well, if I go here to zoom in, or if I do it on a GDC, I find the local minimum around that point, you can see that y goes from 1.485 and above, and below from 4.121. So if we just take a picture of that, and then we will have all our information there. So we can put all of that into here. Okay, so the domain, now there's various ways of doing this, but x is any real number, but x is not equal to 2. And the range, y is less than or equal to -4.121, and y is greater than or equal to, got that wrong, beg your pardon, I was looking at the x number, -15.485, and y is greater than 1.485. So have a look at that. Again, have a quick look and recap on everything and see if you can do example 2 on your own without me having to do it.